Hello, welcome to this discussion of set associative memory. This question is from William Stalling. Okay, not on the current edition but in old edition. A computer system contains a main memory of 32K and 16-bit words. It also has a 4K words of the cache divided into the 4-line sets with 64 words per line. Okay, so these are the data that is given to you, and cache is initially empty, and the processor fetches the word from the location 024051. So total number of words, total total number of words is equal to 4351. These many words this processor is fetching, and then it repeating the sequence 9 more time. Okay, now 4351 words. It required since our block size is 64 words per line, so cache block size is given as cache block size is given as 64 words. So number of blocks required, okay, number of blocks required, and this is always very important parameter, is equal to 435. I have written 1 here, it should be 2 because the indexing start from 0. So 4352 divided by 64, and if you calculate this thing, it required this many access required 68 blocks. So required 68 blocks to access this sequence. Okay, uh, if you look at the main memory, cache arrangement, the cache is having only 4K cache size is 4K words. Okay, and cache size is 4K words, and if you convert into a block size, the number of cache block will be equal to 4 into 1024, that is a value of k, divided by 64, and which is equal to 64 blocks. So number of block available is 64, and number of block available, yes, number of block available is 64, and number of block required is 68. So there is a 4 less number of block present in the cache. Now if you recall and remember that how this elements are being arranged in the cache, so this figure I have already taken here, and the elements, these are basically the set value, because this is my set number 0, consists of 4 block. This is set number 1, consists of 4 block, set 2 and set 3. Okay, and the last set. Okay, so this is also a calculation required here, the number of sets number of sets is equal to total number of block is 64, and it's a 4-way set associative. Now this data is given in the question. Total number of sets are, there are 16 sets. Okay, 16 set, each with 4 blocks. Okay, so this is a set number 0, set up to set 3, this is my 4 set, and the last set will be indexed by the value set 15. This is my set 15. Okay, so now we have a 16 set, and the total number of blocks is 64, required number is 68. Now if this question is about a single round or single iteration, now single iteration, we can answer it directly, that the number of misses is equal to number of block required. Okay, is number of blocks required. Okay, and that is equal to 68. Okay, so but I have to look at the what will happen in the second round, because in the second round few blocks will be available and few block will be replaced because of this extra requirement. So I have to look at the second round, that what exactly happened in the second round and how exactly the data is being means present because of the first time access. So first round it is pretty simple, that is 68. And now we will look at that what will happen in the second round, that once one time is accessing and it come to access another time, how much data is present, means what data is present. Okay, so that we'll discuss in the next part.